this video I am going to solve the model question paper. As you have two model question paper, I am solving model question paper 1. So in that I have considered module 2. I am going to give the complete solution of module 2 in this video. And also you have an advantage of watching this video is I am going to explain the shortcut of solving Markov chain problems using calculator. So here you have the question 3a. So the joint probability distribution of two random variable x and y is given in the distribution. This is what the table they have been provided. So using this table, find the marginal distribution, obtain the correlation coefficient between x and y. See, this problem is very important for you. They have been asked so many times, so you can go through this problem properly. We need to find out marginal distribution. Just add the components along rows and columns. We are going to get the marginal distribution. Along this row, I am going to get the value as 1 by 2. Along this row, I am going to get the value as 1 by 2. Along this first column, I got the value as 3 by 8. Along the second column, I got the value as 3 by 8. Along the third column, I have got the value as 1 by 4. Adding these marginal distribution values, I need to get the value of f of xi, yj should be equal to 1. Reframing the marginal distribution along with respect to x and y. So I have tabulated along x and y. So how to find out along x and y means just so here they have reversed here. The value of y has been given in terms of column and the value of x has been given in terms of rows. Be careful about that. So if they have given the table can also be interchanged. Instead of y here they can give x here and here they can give y. So see to that properly and identify which is x, marginal distribution of x and marginal distribution of y. So with respect to x, the given values are -4 and f of x1 is 3 by 8. When x2 is 2, f of x2 is 3 by 8. When x3 is 7, f of x3 is 1 by 4. That is what I have written here. Similarly, I will find out the marginal distribution of y along column. I have find out that along that column. So I have got those values. Using these values, I am going to find out correlation coefficient, that is row of x comma y. So if you want this row of x comma y, you can go for handbook. So once you go to handbook, so in page number 19, you can find the joint probability distribution. So in that you can also find out the marginal distribution. See here they have been explained how to find out a marginal distribution. Just sum of all these values will be equal to f of x1. Similarly, sum of all these values is equal to g of y1. So like that you can find out what is marginal distribution of x and marginal distribution of y. Nothing to worry. Using a handbook also you can find out easily. Now coming to the point of correlation coefficient. So you can use the formula here. They have given rho of x comma y is equal to covariance of xy comma xy divided by sigma x sigma y. So what is covariance of xy? It is given by e of xy minus e of x into e of y. So for that we need to find out e of xy, e of x, e of y all divided by sigma x sigma y. So for finding that, so we can find out e of x easily. So e of x is given by the formula. Again you can make use of handbook itself. They have been provided how to find out e of x. You can make use of it. I equal to 1 to n xi f of xi divided by xi value is what you can see here. This is what the values. Just now I said this value is x1, this value is x2, this value is x3, and this is f of x1, this is f of x2, this is f of x3. So knowing these values, this is y1, this is y2, this is g of y1, g of y2. So knowing all these values, we can find out f of e of x, e of y. So -4. So here x1 value is -4 multiplied with 3 by 8 plus 2 into 3 by 8 plus 7 into 1 by 4. Similarly for e of y, 1 into 1 by 2, 5 into 1 by 2. So we can solve by using those two formulas. We got the value of e of x as 1 and e of y as 3. So knowing these two, we will move on to find out e of xy. No need of putting comma here. E of xy is given by summation of xi yj pij. In the previous video, I have explained how to find out E of xy. It is nothing but a triangular form. So having the value 1 into minus 4 into 1 by 8, 1 into 2 into 1 by 4 plus 1 into 7 into 1 by 8. So this is how we need to find out. Similarly, going with the second value, that is 5 into minus 4 into 1 by 4 plus 5 into 2 into 1 by 8 plus 5 into 7 into 1 by 8. That is what we have done for finding E of xy. See here. So solving this part, we are going to get 3 by 2. So this is how we can find out the value of E of xy. After coming to know that what is E of xy, E of y, E of x. So find out covariance. Covariance of xy is given by expectation of xy minus expectation of x into expectation of y. Substituting all those values, I got the value of covariance of xy as minus 3 by 2. Then find out sigma x. Sigma x is given by square root of variance of x. Variance of x is given by expectation of x square minus mu x square. Mu x square is nothing but expectation of x itself. So therefore, what is mu x square? It will be expectation of x whole square. So expectation of x, what you got here? 1 you got. 1 square will be 1. 1 square will be 1 here. And expectation of x square is what? Expectation of x square. How to find out expectation of x square means? How to find out expectation of x square? Summation of xi square into p of xi. So just square that value. Minus 4. It is known for you. Minus 4 the whole square into 3 by 8 like that. Plus whatever the value table value you have, is not 3 by 8, I think it is 1 by 8, 3 by 8, 2 square into 3 by 8 plus 7 square into 1 by 4. So solving that, plus 2 square into 3 by 8, 7 square, make that as 7 square, this is not 1 square, 7 square. Simplify this, so you are going to get expectation of x square as 31 by 4 minus 1 under square root, so which will be equal to 2.5981. Similarly, find out sigma y using expectation of y, variance of y. So variance of y is provided by expectation of y square minus mu y whole square. So mu y whole square is nothing but what? Expectation of y whole square. This is what? Mu y square. So solving that part and substituting that in correlation coefficient formula, we are going to get the answer as minus 0.2887. So just I have substituted the covariance of x, y, and here I have find out sigma x and sigma y. I have substituted that part. So substituting those values, I have got this. This is how to solve the marginal distribution and also correlation coefficient. Moving on to next question, finding the unique fixed probability vector of P. I have explained this in my previous video. You can refer my previous video to find out unique fixed probability, how I have solved this. So just I need to find out the value V, that is x, y, z. So that is we need to find out V of x comma y comma z, values of x, y, z. So for that I am going with since applying the definition of probability vector. So once I have considered this as a unique fixed probability vector, so according to probability vector, the sum of these values should be equal to 1. X plus y plus z is equal to 1. Also Vp equal to V. Note down what is V. Note down what is V, what is P, what is V. So I have noted down that part. So after noting that, I have substituted and expanded that part and doing all those things, I got 3 equations here. The first equation is of the form y minus 2x equal to 0. I will name this as equation 1. The second equation is 3 by 4x minus 1 by 2y plus z equal to 0. Equation 3 is of the form x by 4 minus z equal to 0. I will name this as equation 3. And I have one more general equation, x plus y plus z is, that is, I will name this as equation star. So this is what I told in shortcut I am going to solve. So using a calculator we can solve this equation to fetch the values of x, y, z. So after taking out your calculator, go to mode, in that take the option 5 In that, take the option, as we need to find out three unknowns x, y, z. So consider option 2. So in that option 2, we need to enter three equation. So as we have four equation, so out of four equation we need to consider any three. So in that three, which equation we need to neglect means out of these three equations, we can neglect any one equation. So I am going to neglect equation 2. I will consider equation 1. I will consider equation 1, 3 and star. So to solve that equation, now use your calculator. From the first equation, the coefficient of x is -2, coefficient of y is 1, coefficient of z is not there, constant value is also 0. Going with the second equation, that is equation 3, the coefficient of x is 1 by 4, coefficient of y is absent, so it is 0, coefficient of z is -1 and constant value is also 0. Going with the equation star, that is the coefficient of x is 1, coefficient of y is 1, coefficient of z is 1, and this should be equal to, this should be equal to 1. Make this correction. This is not equal to 0, this is equal to 1. So substituting constant value as 1. So now I am going to get the equation of x as 4 by 3. You can verify here. You can, no need of solving these things. You are not supposed, you are in your examination, no need to solve all these things. Directly you can write down x, y, z values. X, y, z values. So we got the values of x, y, z. You can note down. So x value is 4 by 13, y value is 8 by 13, z value is 1 by 13. This is what is shortcut to solve any unique fixed probability or Markov chain problem. Moving on to the next problem, that is of Markov chain. So this is what the problem on Markov chain. Every year a man trades his car for a new car. If he has a Maruti, he trades it for an ambassador. If he has an ambassador, he trades it for Santro. However, if he had a Santro, he is just as likely to trade it for a new Santro as to trade it for a Maruti or an ambassador. So in 2000, in the year 2000, it means in the year 2000, he bought his first car, which was Santro. So find the probability that he has in the year 2002 Santro car, 2002 Maruti, 2003 Ambassador, 2003 Santro. So there is a difference of 3 years. So we need to go with the probability of PQ. We need to go with the 3 transition probability matrix. So first we will define the state space of the given problem. So the given problem is of trading the car of which varieties. One is Maruti, Ambassador, Santro. So for that I am considering ABC. So this is what the state space I have defined, ABC. A stands with Maruti, B stands with Ambassador, C stands with Santro. So now I need to define what transition probability matrix. How to define transition probability matrix? Okay, look at here. How to define the transition probability matrix means the first row. How we can enter the first row values means if he has a Maruti, that is A, he trades it for an ambassador. So in case, how to define transition probability by using the question means, so if he has a Maruti, he trades it for an ambassador. So for that reason, the P will be mapped as what? So as I have defined A, B, C, here also A, B, C. As you know that what stands with A, what stands with B, what stands with the C. So A is Maruti. Maruti trades with what? Maruti trades with ambassador. So for that reason, we will be putting 1 and rest of the values will be 0. Since the probability vector should be equal to, sum of these values should be equal to 1. So next, if he has ambassador, that is next option, if he has ambassador, he trades it for Santro. He trades it for Santro. No other option. So he is trading with Santro. So next, if he had Santro, going with next option C, if he has Santro, he is just likely to trade it for a new Santro, one option, as to trade with it for a Maruti or an Ambassador. So he is trading with all the three cars. So therefore for each values we are going to have a ratio 1 by 3, 1 by 3, 1 by 3. This is how we can find out the transition probability matrix P. So after defining the probability matrix P, we need to find out three regular stochastic forces, three regular values. So with 2000 as the first year and 2002 is to be regarded as what? Second year, and 2003 will be regarded as third year. So we need to find the values of P square and P cube. That is what our aim. First we shall use find out P square and P cube by using your calculator. We can find out P square and P cube. So this is what P square value. So we can make use of this P square value, and this is what P cube value. By multiplying the matrix multiplication, we are going to get the values of P square and P cube. Going with the first question, in the year 2002 he is having Santro. So therefore we need to find out P33 upon 2 is given by what? P33 upon 2. So for the second year, P33 Santro is given by 3, means CC. So P33 upon 2, this is the value P33 upon 2. So 4 by 9 is the answer for Santro. So in the year 2002. Similarly, in the year 2002, you will be having Maruti. So therefore, as he is going to have the Maruti car, so we can have the answer as what? 1 by 9. 3. How to find out? P31 upon 2. So 1 by 9. So another way of solving this, if you are not able to fetch with this value, we can also go with finding P upon 2 is equal to P initial vector into P square. As he is having in the year first starting is having a Santro car. So P upon initial vector can be considered as 0, 0, 1. So by just multiplying 0, 0, 1, you are going to get what is PA upon 2, PB upon 2, PC upon 2. So using this, PA upon 2 will be definitely 1 by 9, PC upon 2 will be 4 by 9. And if they ask for Ambassador also, you can give the answer whatever we are going to get. But I have given the shortcut how to find out the value. So similarly for 2003 Ambassador and Santro is given by the respective values 7 by 27 and 16 by 27. This is how we can find out. See here, this is how I have substituted here. Means what the value will be mapped on to I have shown here. You can just equate those values. You will get the required answer for whatever the problem they have been asked. So in the year 2003 Santro he was having. So answer is 16 by 27. So and also he is having Ambassador 17 by 27 is the answer. So this is how to find out the Markov chain. Moving on to option part. So again we have joint probability distribution of two random variables x and y. They have been provided joint distribution table here. So using this joint distribution table, we need to verify that whether x and y are independent, and we need to go with finding discrete joint probability distribution, probability of y less than or equal to 2, and evaluate probability of x plus y is less than or equal to 2. So for that, again find out marginal distribution of x and marginal distribution of y. Find out marginal distribution of y, and this is what the marginal distribution of x. So after getting the marginal distribution of x and y, if x and y are independent random variable, then we must have what is the formula f of xi into g of yj is equal to pij. So f of x1, I am going with f of x1 into g of y1. What is f of x1 means? This is what the value f of x1, and g of y1 is this is the value g of y1, and what is p11 means this is the value p11 when x is 1, when y is 1. So that is what p11. When I multiply those two values 0.4 into 0.5, I am getting 0.2. So but p11 value is 0.1. So therefore I can say that f of x1 is f of x1 into g of y1 is not equal to p11. Therefore we can say that it is not independent random variables. So similarly, other values also condition is not satisfied. Hence, we can conclude that x and y are dependent random variable. Moving on to next part. The last one is probability of x plus 2 is less than or equal to 2. So we need to know what are the values will be coming with probability of x less than or equal to 2. So when I substitute the value x equal to minus 3 and y equal to 1, we are going to get the values as less than or equal to 2. See, when x value is minus 3 and y value is 1, so definitely the value is minus 2, which is less than or equal to 2. So that is one possibility, and another possibility is when x is minus 3 and y is 3, so we are going to get 0, that is less than or equal to 2. So for no other values, the values will be less than or equal to 2. So when we are going to get that, the possibilities when x is minus 3, that is first value, since x1 is equal to minus 3 in the table and y1 value is 1 in the table, so therefore p11 will be that value. Similarly, p21 x value is minus 3 and y value is 1. We can have these values, so therefore 0.1 plus 0.3 will be equal to 0.4. This is how to solve the problem of joint probability distribution. Moving on to question number 4b. So the question 4b is of definition. They have been asked the definition of probability vector, stochastic matrices, regular stochastic matrices, stationary distribution, absorbing the state of Markov chain. So they can ask any three definition out of this. So or minimum four definition they can ask. So you can see here minimum three they can expect. We can expect minimum three definition from out of this. So probability vector is defined as follows. It is the vector v such that v1, v2, v up to vn. If vi is positive, that is greater than or equal to 0 for every I, then summation of vi is equal to 1. So that is what the probability vector definition. So we have an example. I have provided with one example. You can make use of providing one example. 1 plus 0 is equal to 1. 1 by 2 plus 1 by 2 is equal to 1. 1 by 4 plus 1 by 4 plus 1 by 2 is also equal to 1. So these are all probability vector. Moving on to stochastic matrix. A square matrix P is equal to Pij having every row in the form of a probability vector is called a stochastic matrix. So it is what? It is a square matrix having every row in the form of a probability vector. Whatever the matrix you consider, along that row, the probability probability vector should be equal to 1. So along any row, the value is 1 here. See, I have considered any example. Along this row, the value is 1. Along this row, value is 1. So that's why it is called as stochastic matrix. Similarly, when we say that it is regular stochastic matrix, means if the value, whatever the component or element considered in the probability matrix, that becomes non-zero element, then we say that it is a regular stochastic matrix. The definition says that a stochastic matrix, you consider a stochastic matrix P if is said to be a regular stochastic matrix if all the entries of some power n for positive value. So for positive value means I have considered a here. So for a square, the values are non-zero here. So we can say that the given matrix A is a regular stochastic matrix for n equal to 2 when n equal to 2. Going with another definition, stationary distribution of Markov chain. So if P is a regular stochastic matrix of Markov chain, then the sequence of n step transition matrix, whatever I said for solving the problem of Sandro car problem. So we consider 3 steps, that is after 3 here, like that we are going to find out P square P cube up to P power n approaches the matrix V whose rows are each of the unique fixed probability vector P of P. So whatever the value we consider P power n, that P power n value, whatever the component inside that P power n will be equal to the unique fixed probability vector called V. For example, if we have 3 cross 3 matrix, so unique fixed probability vector V is given by x, y, z, the value of xyz will be equal to as same as the matrix what we are going to have p power n. The element of x will be equal to p11 upon n, like that. Similarly, p33 upon n for z, like that. So we have p power n is equal to p upon 0 into p power n. As n tends to infinity, the value will be equated to vi, that is unique fixed probability vector, where I is equal to 1, 2, 3 up to n. So this is called stochastic stationary distribution of the Markov chain. Moving on to the definition of absorbing state. So definitely there is chances of asking absorbing state and regular stochastic matrix, precision matrix, all those things they can ask. So be thorough with this definition. There is no other option. You don't have other option. You need to buy it, or you need to know the concept at least. In a Markov chain, the process reaches to a certain state, after which it continues to remain in the same state. Such a state is called absorbing state of the Markov chain. So if you go with a certain process, if you do certain process, that is p square p cube or like that, if you are doing, then the state space will not changes. It will be fixed on to one state. It means he will be purchasing again and again. He will be purchasing Santro, means he has been fixed to one state. He is not going to any other state. Such states are called as absorbing state. Just I am taking the example of Santro car itself. So that is called as absorbing state. Here I have given the example. You can go through the example. So that value will be here the state A3 and A4 are absorbing state. So here there will be no change after these 1. If you come with 0 0 means 1 means along that probability vector, it is fixed. So moving on to the next column. A salesman's territory consists of 3 cities A, B and C. He never sells in the same city on successive days. If he sells in a city, then the next day he sells in the city B. You go through the statement here. So using this statement, I need to find out first transition probability matrix P. So for that reason, I will define the state space as ABC. So we require to find out how long in the long run the salesman sales 40% in a city A, 45% in a city B and 15% in a city C. We need to solve this. So let us see to define probability matrix. So if they have considered that if he sells in city A, then in the next day he sells in the city B. So we can consider that value as 0, 1, 0. So next what he is going to do, however, if he sells in either B or C, so he is going to sell the value in B or C. So therefore, since we have 3 cities, it has to be divided with the ratios. So B along with A, B and A and B with C. Like that we are going to get 2 by 3 and 1 by 3 ratio for BA and BC. So similarly for CA and CB we are going to get 2 by 3, 1 by 3. There is no selling anything along the same cities. They are not selling anything along the same cities. So if they are moving to other neighbor cities, that's why the value is along the diagonal elements, the value is 0. In the long run means we need to find out unique fixed probability vector. Go with Vp equal to V according to the definition. So substitute V as x, y, z. So you know that substituting all these things and expanding this matrix, we are going to get 3 equation as I said. So I will consider this as equation star. Using these 3 equation, out of these 3 equation, I will consider any 2 equation to solve. Use your calculator. I will rewrite this equation as 3x minus 2y minus 2z is equal to 0. I will name this as equation 1. From second equation, x minus y plus z by 3 equal to 0. Name this as equation 2. And here y minus 3z equal to 0. Name this as equation 3. So to solve this equation, I can consider equation 1, 3 star. So solve this 3. So I'm going to get the equation values. No need of solving all these things. Directly you will get the value of z, x, y you are going to get. So note down that and end up with the solution. So this is how to solve the problem of Markov chain. This is a very shortcut way we can solve. No need of simplifying more. So you can remove all those things simplification. Just make use of your calculator to solve this simultaneous equation to get the values of unknowns called x, y, z. So if you have any doubts, you can put a comment and kindly do subscribe to my YouTube channel. Also share this video. It may be helpful for some other one if it is not helpful for you. So kindly share this video with your friends. Thank you all for watching this video.